So picture this. You step back in time. Maybe you're standing next to an archaeologist, right? And they look pretty weary. They're squinting at this old stone slab. It's sun-bleached, cracked. You can see letters are missing. And, for decades, scholars have been arguing over what it actually said. It's like this ancient puzzle, a voice lost to time. But now, imagine something stepping into that dusty drench with them. Deep Mind Aeneas. It's this, well, revolutionary neural network. You basically feed it a photo of the inscription, give it a transcription with all those gaps, and bam, it suggests restorations. It estimates the date. It even proposes where the stone was first carved. It's like we're bringing lost voices back. Not with magic, obviously, but cutting-edge AI. And this isn't sci-fi anymore. It's a real tool epigraphers are using now. So our mission in this deep dive is to explore how this AI for history works, how it weaves together image processing, language modeling at the character level, finding parallels, and how it's really transforming digital archaeology, helping restore text with incredible nuance.
Yeah, and what's truly remarkable here, I think, is that it's not just some black box spitting out text predictions. It's not simply guessing words. It's been designed really from the ground up to understand historical context. And that fundamentally changes how we interact with these ancient sources. It's a whole new ballgame.
Okay, let's unpack that. How exactly does this AI reason? What's it built on? Its starting point?
Well, Aeneas was trained on a huge foundation, the Latin epigraphic data set, LED for short. We're talking like 176,000 inscriptions. Massive. It spans from the Roman Republic right through to the early Middle Ages. And these records, they combine the text with lots of metadata, but critically, many have missing bits, lacunae, as scholars call them. Some even come with images, which is key.
Right, and I heard there was a really clever design choice about how it handles the actual language. It doesn't just look for modern words, it looks at the raw characters. Why is that so important for ancient stuff?
Precisely. That's absolutely vital because, ancient texts, they're full of archaic spellings, weird abbreviations, broken words. If you tried to use a standard, modern, word-based vocabulary, it would pulverize all that nuance. Think about trying to read Roman shorthand with, I don't know, a modern dictionary. It just wouldn't work. By focusing on characters, Aeneas can hold on to those tiny, subtle linguistic clues from history.
Okay, got it. So let's simplify the brains a bit. How does it actually process all this? The text, the pictures?
Okay, so at its core, it uses something called a slimmed-down T5 decoder. Think of it as the AI's language brain. But it's enhanced with rotary embeddings, making it super sharp at spotting ancient Latin patterns, even faint ones, like a specialist linguist. And for the vision side, it uses a ResNet. That's basically its digital eyes. It analyzes the photos, the textures, the shapes on the stone, and boils those visual clues down into feature maps. These are like the AI's detailed notes on what it physically sees in the stone.
So the ResNet is literally learning to read the stone itself, not just the letters.
Wow. And then these two bits, the text analysis and the visual notes, they come together.
Exactly. They converge in what the researchers call the torso. And from there, the combined info branches out into 4 specialized heads. Each one has a specific job.
4 heads. Okay, what do they do?
Right. So one head tackles text restoration when you know how many characters are missing. Another one does restoration when the gap size is a total mystery, which happens a lot. Then there's a geographical head. It predicts where the stone came from across 62 Roman provinces. And it uses those image features too.
Okay.
And finally, a dating head. It estimates the date in 10-year chunks, all the way from 800 BCE to 800 CE.
That's a massive time frame. So these heads aren't just working alone.
No, exactly. Their outputs, their sort of intermediate thoughts, they merge into one single, really powerful, historically rich embedding. Think of this embedding like a compass. It guides a retrieval engine.
A compass, right. Allowing it to instantly pull up other inscriptions from that huge data set that have similar phrasing, maybe similar pictures, or the same kind of social context.
Okay, so let me see if I get this. It's like you give it one tiny piece of an ancient puzzle, and it doesn't just guess the next piece. It instantly finds you hundreds of other puzzles that look just like yours that are already solved. That saves, wow, weeks of searching.
Precisely. Yes, that's a great way to put it. The breakthrough is that scholars get this automatically generated reading list, something that could have taken them weeks, maybe even months to dig up manually. Imagine you feed it a photo of some obscure cavalry officer's altar, and it just quietly points you to, say, half a dozen similar stones, put up by his buddies, maybe a province over, dated within a few years, using almost identical language. All that legwork. It shrinks from potentially days in the library down to like a coffee break.
That is absolutely a game changer. So let's talk about Aeneas in action. Any sort of aha moments from the field? I heard the ultimate test was the Res Gestae Divi Augustus's famous autobiography.
Indeed, that was a big one. It's this huge text, carved on bronze on temple walls, and historians have debated its exact dating, its composition, for centuries. So Aeneas looked at the Res Gestae chapter by chapter, but crucially, it was told to ignore the obvious date clues, like mentions of consuls,
Okay, why ignore the easy stuff?
to force it to rely on subtler clues, its saliency maps.
Ah, yes, the saliency maps, they show what the AI focused on, right?
Here-
Like highlighting.
Exactly. They show what parts of the text it found most important. And these maps lit up on things like archaic spellings, certain titles, these tiny chronological breadcrumbs.
And the result?
The striking thing was it produced a bimodal date distribution. 2 peaks. One peak around 5 BCE, another around 15 CE. Now, that wasn't just some random guess. That pattern perfectly mirrored 80 years of intense scholarly debate about when the text was composed, all from just those subtle language cues.
That's incredible. It basically replicated decades of human detective work in, what, minutes? Hours?
Pretty much. But it got even more interesting. It also surfaced stylistic parallels, connections to 2 Senate decrees praising Germanicus, decrees that were etched decades after Augustus died.
Okay.
Human scholars had suspected this kind of borrowing, this ideological echo. But Aeneas found the epigraphic fingerprints, the specific stylistic quirks, in seconds. It really reinforced this idea that imperial propaganda just rippled across the provinces, almost like a viral meme back then.
Wow. Okay, that's impressive for big imperial stuff. But what about, more everyday things? Did it uncover stories from the barracks, maybe? The Mainz votive altars?
Yes, definitely. A good example is from Mainz, or Moguntiacum, as it was called.
Yeah.
In 211 CE, a soldier, Lucius Maurius Cogitatus, puts up this limestone altar. Pretty standard stuff. Now, a century of human cataloging had found hundreds of similar stones from Mainz, but the best parallel, the closest match, wasn't found until 2007 during an excavation. It was a second altar dated earlier to 197 CE, and it's still missing from most standard databases today.
Okay, so it wasn't widely known.
Right. But DeepMind Aeneas, when analyzing Cogitatus's stone, ranked this unseen, recently discovered altar as the #1 match.
Whoa. How? Why was that such an aha moment?
Because the earlier altar had an almost identical prayer, very similar slab design, even the same dedication month, July. The model had seen the text of the newer inscription because it was in an updated data set it trained on. But, and this is the kicker, it had no location data, no coordinates, to tell it that these 2 altars once stood literally within a few paces of each other.
No way.
That crucial archaeological connection, that came from the humans after the AI pointed out the textual similarity.
That's incredible. It's like finding that needle in a haystack, but the AI also tells you, hey, this needle is the exact same type as the one you're holding, even if you didn't know the second needle existed.
Exactly.
It spotted this rare phrasing, this niche religious combination, stuff that simple keyword searching or fuzzy matching would totally miss.
And that's just priceless for archaeologists in the field trying to make sense of fragments. That pattern recognition is huge. It connects dots that could stay hidden for years.
Okay, so the potential is clear. But how do we actually measure the payoff? How much better do humans really work with this AI help? Was there an experiment?
Oh, yes, a rigorous one.
Mhm.
The team got 23 epigraphers together. A real mix. Grad students, tenured professors, the lot. They gave them 60 inscriptions to work on, but under 3 different conditions.
Okay, what were the conditions?
First, they worked completely solo, just their own expertise and a big spreadsheet of reference texts. Standard practice, really. Second condition, solo again. But this time, Aeneas gave them 10 suggested parallel inscriptions for each text they tackled.
Like a hint list.
Exactly. And the third condition, they get the parallels plus Aeneas' own predictions for the missing text, the date, the province, the full package.
And the results. What was the big takeaway on the human AI teamwork?
The headline was just crystal clear. Partnership wins. Hands down, take text restoration. The average error rate, how many characters they got wrong, dropped from 39% when working alone down to just 21% with the full AI support. That's a huge improvement.
Wow, nearly half the errors. What about finding the location?
Geographical attribution, yeah. Top 1 accuracy, get the province exactly right, jumped from 27% solo.
Pretty tough task solo, I guess.
Very tough. Jumped from 27% to 68% with full AI support. Remarkable.
68%.
And dating. Dating errors shrank too. The average error went from being off by 31 years down to just 14 years.
Incredible improvements across the board, but was it just about accuracy? How did the experts feel?
That's a great question. It wasn't just accuracy. Confidence levels shot up. Experts felt about 23% more confident just with the parallels. Then another 21% more confident when they got the AI's predictions too. So roughly 44% more confident overall.
That's significant.
It is. And even the really seasoned pros admitted the machine's suggestions nudged them, pointed them to inscriptions they'd missed or timelines they hadn't considered. And crucially, the researchers made a point of saying no one felt replaced. They felt superpowered.
Right. Here's where it gets really interesting. It's not about replacing the human brain. It's about amplifying it. You're not just getting answers spat out. You're getting a clearer, more confident path to those answers.
Precisely. And this raises an important point about, the nature of this collaboration. The numbers really ground Aeneas in the real world. They show the biggest leaps happened when historians blended the AI's suggestions with their own critical judgment. Just relying purely on the AI, performance plateaued a bit. But human-AI collaboration, that kept climbing. It's just such a powerful reminder that AI for history really shines when the scholars are the ones steering the conversation, asking the questions.
That's a critical point. So zooming out again, why does Aeneas fundamentally change the rules for the whole field of epigraphy?
Well, traditionally, being a top epigrapher meant having this almost encyclopedic memory, right? Years and years spent absorbing formulas, abbreviations, names, places from all over the Roman world. It's incredibly demanding. Aeneas offers, well, think of it as a second memory brain, one that never gets tired, never forgets. You can scan the entire known Latin corpus in, a few GPU cycles. Seconds, basically.
Instant recall of potentially every relevant inscription ever found.
Pretty much.
That alone must change the day-to-day work drastically.
Absolutely. Tasks that used to mean expensive flights to archives in Rome or Naples. Now they unfold in browser tabs. The speed increase is phenomenal.
Right.
And scope. Scholars can test ideas across the whole Mediterranean, not just one region they specialize in.
Inequity, too, you mentioned.
Yes, researchers far from the big libraries, maybe at smaller universities, they get the same super fast access as professors sitting in Rome or Oxford. It levels the playing field.
Democratizing access, really.
It really is. And for discovery, those rare outliers, the really unusual inscriptions, they pop out more easily because the model has such a broad baseline of what's normal.
So what does this all mean for the daily work of a historian? It sounds like it's democratizing access to historical knowledge in a big way.
Absolutely. And, this also brings up the important question of critique. People worry, rightly, about researchers just blindly trusting the AI. And they should worry. No scholar should ever accept a neural network's output without interrogating it, without checking it.
Of course.
But the alternative is, well, it's slower, it's narrower in scope, and often the results are less reproducible from scholar to scholar. With tools like saliency maps providing transparency and these peer-reviewed benchmarks we talked about, Aeneas actually invites inspection rather than hiding its workings.
Okay, so it's not just a black box. And it goes beyond simple keyword searches, right? That feels like a key difference from older digital tools.
Huge difference. Previous digital humanities projects did amazing work, digitizing texts, tagging parts of speech, building databases, essential groundwork. But Aeneas adds the vision component, that powerful retrieval engine, and the generative restoration, all in one package. It pushes digital archaeology into what you might call contextual reasoning. It gives suggestions based on both the language and the physical stone itself. It understands the link.
Okay, so this sounds like a real step up. How did it actually stack up against other AI models? A clash of the titans, perhaps. You mentioned Ithaca.
Right. So Ithaca was kind of the previous state-of-the-art AI specifically for epigraphy, though it's designed mainly for ancient Greek texts. And there's also a simpler baseline method called the onomastics baseline, which just tries to guess date and place by looking at personal names.
Simple, but maybe sometimes effective.
Sometimes, but limited. So they tested the new Latin-focused Aeneas against both, and the results, Aeneas beat Ithaca on every single shared metric, even though Latin, with all its abbreviations, actually makes text restoration technically harder or nastier than Greek.
Wow, okay, give us the numbers. Restoration.
Character error rate for restoration. Aeneas was at 40.5% error, Ithaca was 48%, and the names-only baseline was way up at 64% error. So Aeneas was significantly better.
Okay, and finding the location. Geographical attribution?
Top 1 accuracy. Aeneas hit 72%, Ithaca was 59%, and the names-only baseline, only 18%. Massive difference there.
Huge gap. Dating.
mean error in years for dating.
Yeah.
Aeneas was off by only 13 years on average. Ithaca was 18 years. And the names only was off by 45 years.
If we connect this to the bigger picture, it really hammers home how much Aeneas outperforms older methods.
It does. It highlights that it's learning simultaneously from syntax, iconography, even from partial bits of text, in a way previous models just couldn't. It's a real leap in automated analysis for this field.
Okay, impressive performance. But like you said, every powerful tool casts shadows. Let's talk about the caveats, the potential challenges.
Delete the shadows. We have to be aware of them. One is potential bias. If the training data, the LED data set, leans heavily toward, say, inscriptions from the imperial elite in Rome.
Which it might, historically.
Exactly. Then the model might learn to over-predict Rome as the origin for inscriptions found elsewhere. It might develop a Roman bias. Improving the geographical balance of the training data is definitely on the roadmap for future work.
Makes sense. And data scarcity for images is still a thing.
Still a thing. Only about 5% of that huge data set actually includes images. So right now, text features are still driving most of the predictions. The team really wants to get more images of different kinds of inscriptions like, cursive graffiti scratched on walls, lead-cursed tablets, mosaics. More visual variety will definitely help train that vision head to be even smarter.
Okay. And what about the circularity issue, the model learning from human guesses?
Yeah, that's a valid concern. In many published inscriptions, editors have already filled in missing letters, often putting their guesses in brackets. Now, the team kept these bracketed guesses in the training data to avoid shrinking the dataset too much.
But the worry is...
The worry is a feedback loop, right? The AI learns from a human guess and then later confirms that guess, making it seem more certain than it is. They did run a test removing the brackets, and it only hurt performance by about 5%, which is interesting. But building clean data sets without those editorial interventions is something they're considering.
Okay. And the final concern was about how people might misuse it, like students just copying answers.
Usage drift, yeah. The worry that maybe students would just copy-paste Aeneas's restorations into essays without citing it or without critical thought. But the public demo version is quite clever about this. It flags every AI-generated completion clearly as hypothetical and clickable. You click on it, you see the evidence, the parallels it used. It turns it into a teaching moment, really, a lesson in source criticism.
So it's a powerful tool, definitely not perfect, not a silver bullet, more like a very, very effective magnifying glass, but one you need to use thoughtfully, aware of these considerations.
Absolutely.
Yeah.
And these caveats, they don't dampen the excitement, not at all. They just call for responsible development. Transparent interfaces, rigorous testing, ongoing peer review. That's how you ensure innovation happens responsibly in a field like history.
So looking ahead then, what are the next frontiers for Aeneas or tools like it?
Well, one big one is multilingual expansion. Applying this approach to other ancient languages. Imagine using it on ancient Greek corpora, Coptic, Hebrew, Demotic, and think about the possibilities. Finding cross-lingual parallels could reveal so much about trade routes, cultural diffusion, how ideas traveled.
That's exciting. And the vision side getting richer.
Definitely. Imagine Aeneas learning to read even subtler visual cues, like the angle of chisel marks or traces of ancient pigment.
Wow.
Things that could give much more precise dating clues. That needs more structured image data sets, but the potential is there.
And you mentioned maybe talking to the AI.
Yeah, dialogue-first interfaces. The idea that you could just converse with it. Ask it things like, hey, Aeneas, show me inscriptions, using the phrase Ordo Decurionum in North Africa between 50 and 150 CE.
And then refine it.
Exactly.
Yeah.
Then maybe say, okay, now narrow that down to ones found near Carthage. A proper back-and-forth refinement. That could be incredibly powerful.
That sounds amazing. And can people actually try this out now?
Yes. For listeners who are curious, DeepMind has open-sourced the whole toolkit. It's on GitHub. Search for Predicting the Past. You can get the trained models, the code, everything. There's even a Colab notebook, which gives you a pretty easy, no-setup way to play around with it.
Fantastic. And it's already being used outside pure research labs, in classrooms.
It is. There was a great example with high school seniors in Ghent at St. Leven's College. They used Aeneas for a project, but they were encouraged to critique its suggestions, not just accept them. And one group actually found a case where they thought Aeneas had likely made a misattribution.
Huh. That's brilliant.
It really reinforces the point, right? AI restores the text, but human eyes still referee the match.
Perfect. And museums, too.
Yeah, discussions are happening. The British Museum, for example, is exploring integrating Aeneas into interactive kiosks. Imagine visitors being able to walk up to a stone display, maybe try out their own reconstructions on a screen, and then compare them to what the model suggests, make it interactive.
That would be fantastic. So it's really clear DeepMind Aeneas is changing these Latin inscriptions from just static, old objects into interactive clues, dynamic puzzles we can engage with. It feels like a huge shift. From, decades of painstaking work deciphering fragments to a grad student dragging a photo into a web browser and seeing potential restorations just bloom on the screen in milliseconds.
It really is a shift. And again, it doesn't replace the fieldwork, the thrill of digging something up or the deep historical analysis, but it fundamentally rebalances the hours. Less time spent hunting through microfiche or card catalogs.
What's the microfiche?
Exactly. Less of that, and more time freed up to ask the big, ambitious questions. Questions like, how did imperial propaganda actually ripple out into local religious practices? Which trade routes were fastest for spreading legal formulas? Was it faster than spreading new pottery styles? How did one specific archaic spelling travel all the way from Rome to the Rhine frontier? Those kinds of deep dives.
It really brings us back to the name Aeneas, the mythical hero wandering from fallen Troy, carrying just a fragment of memory, a legacy, to found something new. And now, in 2025, we have this neural network carrying fragments of literally thousands of ancient texts, reassembling them in silicon, and handing historians this incredible new compass to help navigate the past.
It feels like the Silent Stones are beginning to speak again. And this time, the chorus includes both us carbon-based scholars and our silicon-based colleagues.
A powerful image to end on. So, as you, our listeners, think about this incredible symbiosis between human expertise and AI, what other historical mysteries spring to mind? What other untold stories might be out there, just waiting for this new kind of partnership to bring them back into the light?